Okay, thank you, Peter, for that introduction and for everyone coming out to learn about the Foreign Comparative Testing Program. As mentioned, I'm Colonel Doug Creviston. I'm in the Comparative Technology Office, which is within the Office of Secretary of Defense Research and Engineering with other prototyping programs. And the purpose of the Foreign Comparative Testing Program, if I could get the next slide. Pushing the right button there. Yeah, the purpose, I'll go ahead and explain just the overview. The purpose of the program is really to go out and find the best technologies in the free world among our allied and partner nations and provide an avenue for those technologies to be evaluated and then to move into expedited acquisition or procurement by the U.S. DoD. So we recognize that there's great ideas all over the world, lots of innovators here in France, among our other allied and partner nations, and we're trying to find the best ideas and on a competitive basis select those for evaluation where they can insert rapidly into U.S. procurement. We do that to enhance the military capabilities. That's the bottom line, is at OSD we're trying to find these technologies that are going to answer operational needs and really fulfill those requirements in a cost-effective way, in a rapid way for getting that innovation to the field. So we're looking for the three big tenets of program management: a technology or a product that provides an advantage in cost, or an advantage in the fielding schedule, or an advantage in performance. Folks often ask which is most important. I would say, as an operator, performance is most important in terms of you have to at least meet a minimum performance baseline. But once you've met that minimum baseline, then cost or the fielding schedule can really kind of take over and be the driving force for doing a project. And then finally, we're just looking for novel, innovative technologies. Sometimes the U.S. has embarked on a particular approach to solving a problem, whether the problem is getting fresh water to the soldier in the field or the problem is delivering weapons on a target through coordinated air and ground force communication. The approach that we've taken often involves a systems engineering approach. We divide the problem up, we assign different responsibilities to different organizations, and then we source technologies to fill those different responsibilities. But if our approach is different from an approach taken by France or by some other partner nation, we may want to understand how you have an innovative technology that crosses perhaps a seam in our organizational approach to this problem. Or we may have taken an approach that's running out of the potential to be upgraded. So the example I like to use here would be internal combustion engine propulsion for a car, right? For years, that technology was refined. It was giving more and more efficiency. But at some point, you're not going to go past 40 miles per gallon. I apologize for using English units here. You're not going to get past that level of efficiency with an internal combustion engine. And so now you see the introduction of hybrid power plants or even electric power plants. And that approach is going to be able to continue to be refined into the future. So when we in the FCT program see a novel, innovative technology that's totally different from how the U.S. has solved a problem, that can be very attractive. Kind of the second major thing that we're doing with FCT is connecting foreign industry and foreign researchers with the U.S. Department of Defense acquisition process. That process is complex. It's Byzantine. We give the Byzantines a run for their money on the definition of that process. We understand that it can be difficult, especially for a small or medium enterprise overseas, to understand the U.S. DoD process. So we want to be a front door to say, just show us the technology and we'll connect you up with the right researchers, with the right program managers. And then finally, one of the major reasons for having this program be funded at an institutional level at the U.S. Department of Defense is that it supports our reciprocal defense procurement. We, in the U.S., export a lot of final, complete weapon systems, and we recognize that our allies in order to get a good return on their investment, are often looking for some traffic to come back the other way. And so when we're out there looking for those innovative technologies, we're also, we believe, supporting the overall reciprocal defense procurement of arms going in both directions with our allies. And that really supports interoperability. We're looking at the same problems, we're aware of each other's technologies, we're aware of each other's procurement processes. The bottom line here is that OSD, my office within the Office of Secretary of Defense, selects and then funds projects using the money that Congress has allocated specifically for this purpose of going out and finding and bringing in allied and partner nation technology. The military services and then U.S. Special Operations Command execute the evaluations under the Foreign Comparative Testing Program. That's important because those organizations, the military services, the Army, the Air Force, Navy, Marine Corps, and Special Operations Command have the final acquisition authority in most cases. So we're working directly with the people who will make the decision about full rate production, full rate procurement, and fielding in order to make sure that they are truly interested in this technology and we're not wasting your time by having an evaluation that's not really connected to a transition path. We think the FCT program has been successful on a number of levels, and I just want to outline a few of those here. The OSD has invested $1.4 billion into the evaluation of allied and partner nation technology. That's led to procurement in about 280 cases, worth over $11 billion. And that's kind of the initial contracts. There's a lot of follow-on contracts that are not captured in that number. The number I'd really love to share would be how much we've saved the U.S. taxpayer by going out and finding an existing solution instead of funding R&D. That's a much harder metric to come up with since it involves alternate, kind of the alternate future. What we are pretty confident is that we accelerate fielding an average of 2 to 4 years instead of starting from square one or from TRL 1 or 2. When we go out and find a ready technology or a ready product, then that product can get in the field much faster. And that's becoming so much more important with the rapid acquisition and the innovation cycle accelerating. We, in order to really keep pace with the innovation cycle, have to be getting those things into the field more quickly. I do want to make a pitch and an argument that this program has even enhanced the U.S. industrial base. It's not a requirement to participate in FCT that you have a partnership with a U.S. company. We go through the evaluation. In most cases, the final procurement doesn't even have to be made in the U.S. But we have found that many participants in FCT have made the decision on their own that they wanted to either partner with a U.S. company or set up a production facility in the United States, because that's given them the best access to the customer, the best ability to remain competitive as they continue to develop their product. That's happened in about a third of the projects where procurement occurred and has benefited 34 of the 50 states of the Union. Just to give you an idea about scope, with FCT we're not generally evaluating a technology or product throughout the entire acquisition process. We're trying to do a bounded evaluation that answers a few key questions. What's the operational problem we're trying to solve here? What foreign technology or system do we think solves it? And what's the evaluation that we need to do to give the necessary data to the program manager to make an acquisition decision, to move forward with the acquisition process? So we try to keep those evaluations pretty small and fairly rapid. The average project is funded at about $500,000 to $700,000 US per year for a 1.5 to 2 year period of performance. And we look at over 1,000 technology. I think I've seen over 1,000 technologies just here at the Paris Air Show. But we really get in depth, one-on-one meetings, get more in-depth information for over 1,000 technologies each year, and that goes through a very competitive process to end up in 15 to 20 new starts. The Foreign Comparative Testing Program works with technology readiness level 6 through 9 technologies, and a key reason for that is to manage intellectual property rights correctly, and in an effective way that's attractive to our foreign partners. So with TRL 6 through 9 technologies, under the FCT program, those technologies are being tested, they're being evaluated, they are not being developed. And thus we are not creating intellectual property, and we are not affecting the intellectual property or the ITAR status of the technologies that are being evaluated under this program. We understand that ITAR is a major concern for a lot of our allied and partner nation companies. We don't want to have that additional burden of creating a limit on how you would be able to market that product to the rest of the world. So we're doing an evaluation, we're not doing development. With technology readiness level 6, that evaluation of the product might be supporting or transitioning into a developmental prototype that then would go into a technology development roadmap. With a technology readiness level 8 or 9, where this is already fielded with a partner nation's military or in use in the commercial sector, that's often just a qualification test. Often for these very mature technologies, in this case, there's a well-established requirement or specification. We're just testing against that requirement, and then if it passes, then it can go into procurement. FCT projects might be side-by-side comparative evaluations, and generally we find that foreign companies are attracted to that. They see that if you're evaluating a domestic solution or two against a foreign partner solution, that's exactly the kind of comparative evaluation that they are looking for and that they think will allow them an entry into the U.S. market. And so those comparative evaluations are explicitly authorized in Title 10 U.S. Code, a U.S. law that authorizes FCT, and under that law, they satisfy the requirement for full and open competition to move to procurement if done correctly. So what is the focus areas, the kinds of technologies or operational problems that FCT is trying to solve? Well, we take our direction from the National Defense Strategy of the United States, which I would recommend for anyone who's seriously trying to get involved in this program, that you take a look there and try to frame how your technology applies to that National Defense Strategy. But the first line of effort under that strategy is readiness and joint lethality in contested environments. So this is what you would think of as the standard military mission, the ability to strike the enemy and the ability to deploy, survive, sustain, and operate while conducting these operations. The key words here with our new strategy is the contested environment. So we expect in the United States that we're going to be contested in the cyber environment and that our systems will need to be cyber hardened. We're expecting for any kind of radio communication systems or control links that those control links are going to be contested with jamming, possibly with cyber attack, et cetera. So the systems need to be able to operate in a contested environment. The next focus area are these modernization technologies, or these technology areas that have been identified as the most important for us to develop capabilities in going forward. So these includes things like space, missile defense, hypersonics, directed energy, quantum technology. A lot of these areas, fully networked command, control, and communication, this is the application of 5G technologies to the military mission set, or quantum technology or machine learning. These are areas that are being developed by the commercial sector and the universities around the world. These are not uniquely American specialties. Although America is great in a lot of these areas, we have a lot of potential partner nation products that are competitive in these areas as well. You might also think about something like hypersonics and say, well, that's really challenging. But even material technologies or manufacturing technologies that are appropriate and enablers in these areas can be attractive to the foreign comparative testing program. The last two bullets we always want to keep an eye on. So urgent operational needs there's a formal process in the United States to say we're in a combat operation or we're in any operation that's assigned to the DoD, and we have an equipment shortfall. We need to satisfy this rapidly. The foreign comparative testing program is often a great way for addressing that urgent operational need, because perhaps some other nation, because of their operating environment, has had to deal with and address this problem already. It wasn't in the US technology roadmap, but perhaps it was in France's technology roadmap or another partner nation. And so we can very quickly, with FCT, go evaluate those finished products that our allies have and bring them to the field rapidly to satisfy that urgent operational need.